Hi, today we're looking at Functional Skills Maths Level 2. This is the TQUK Functional Skills Exam Board. We've got examination past paper 7 and we're going to start with the non-calculator section. Question 1. Work out 1.804 plus 2.6. So let's write these out. 1.804. Then we're going to write the 2.6 below, but we want to line up the decimal points. So we're going to have the 2 here and the 6 here. And so we've got something to add these two. I'm just going to insert some zeros. So now we've got 4 plus 0 is 4. 0 plus 0 is 0. 8 plus 6 is 14. 4 carry the 1. Bring down the decimal point. 1 plus 2 is 3, plus 1 is 4. So we've got an answer of 4.404. Question 2. Work out 5 times 6.248. Okay, so first thing I'm going to do is write this number on top, 6.248. Now, sometimes I'd write it without the decimal point. It doesn't really matter too much. What I'll do here is we'll leave it in for now, and we'll see how we get on. Okay, I'll show you how we can do a check to see whether the answer is looking sensible. So we'll start off with 5 times 8. So we've got 8, 16, 24, 32, 40. That's fine. So 0 carry the 4. Then we've got 4 times 5. So we've got 5, 10, 15, 20. Plus the 4 is 24. 2 times 5 is 10. Plus the 2 is 12. 2 carry the 1. I'm not going to put the decimal point in straight away. Now we've got 6 times 5. Or we can do 5 times 6. 6, 12, 18, 24, 30. Plus the 1 gives us 31. Now, we've lined it up so we can just put the decimal point in here. But if you're not sure about that, where to put it, because it can be a bit confusing at times, you can leave the decimal out completely. And then when you get to your final answer, say, well, how many decimal places did we have in the question to start with? Well, we've got no decimal places here. We've just got a whole number. And we've got 1, 2, 3 decimal places here. So starting at the end, we go in 1, 2, 3, and we would put it in there. Okay, so we get an answer of 31.24. We don't need to include the 0 because it's at the end. Now, I said about doing a check. What we can do is say, well, 6.248 is close to 6. So if we did 5 times 6, we'd have 6, 12, 18, 24, 30. So we'd expect an answer close-ish to 30, and it's 31.24. So it looks sensible. If we had put the decimal point in the wrong place, then our check would highlight that straight away, because we'd either end up with 3 point something, which would obviously be too small, or 312 something, which again would look too big. So it's nice to do a little bit of quick rounding, check the answer looks reasonable, and then we can move on. Question 3. This is a scale diagram of a floor plan of a house. We've got the kitchen area and the living room. And we've got the distance across here, 4.5 centimetres. The scale is 1 to 200. So that means 1 centimetre on the drawing is 200 centimetres in real life. Work out the actual length of the living room. Give the units in your answer. Okay, so if 1 centimetre on here is 200 in real life, well, 4.5 centimetres on here, in other words, 1 times 4.5, is going to be 200 times 4.5 centimetres. So, we want 200 times 4.5. I'm going to ignore the zeros and ignore the decimal point. So we've just got 2 times 45. So let's write that out here. 2 times 5 is 10. 2 times 4 is 8, plus the 1 is 9. So we've got an answer of 90. Now remember, it's not 2, it was actually 200. So we've got 2 zeros to add on. So we can add 2 zeros there. But then it wasn't 45, it was actually 4.5. So we've got 1 decimal place, so we're going to put the decimal point in there. So the answer that we get is 900, and that's going to be centimetres. If you want to write it as 9 metres, that's absolutely fine. They haven't specified which units to use, just as long as you do use units in your answer. Question 4. Work out 1/4 plus 1/7. Well, with fractions, when we're adding them, we always look and see if the denominators are the same. They're not, so we can't add them straight away. We look, does one denominator go into the other without remainder? Well, no, 4 doesn't go into 7 nicely. So that means we're going to have to change both of the fractions to get the same denominator. And we can either look for the lowest common factor, lowest common multiple. So that's the smallest number that's in both the 4 times table and the 7 times table. Or a quick way of doing it is just by multiplying these two numbers together. So 4 times 7 will be 7, 14, 21, 28. So what that means is we can write both of these fractions as being over 28. So we know what our common denominator is. We just got to work out what the numerators are going to be. Well, 4 into 28, well, we saw we multiplied it by 7. So that means we're going to have to multiply the top by 7 as well. Well, 1 times 7 is just 7. Similarly, to get from 7 up to 28, well, we multiplied it by 4. So we've got to multiply the top by 4 as well. And 1 times 4 is 4. Now we've got the denominators the same, so that's going to stay as it is. And we can just add the 7 and the 4 to give us 11 over 28, which we can write in our answer box. Question 5. Charlie receives these discount coupons for the same restaurant. So Monday is 1/6 off. Tuesday, 16% off. Charlie wants to go to the restaurant on the day which offers the bigger discount. On which day should Charlie go to the restaurant? Show how you decide. So we've got the value written as a fraction and the value written as a percentage. We want to be able to compare them. So what I'm going to do is I'm going to change this fraction into a percentage. And to start with, I'm going to turn it into a decimal first of all. So 1/6 actually means 1 divided by 6. And if you think, well, how would we do that normally? Well, normally we would use a bus stop method. And we'd put the 1 inside and the 6 on the outside. Well, 6 doesn't go into 1. So what we need to do is write the 1 as 1.0, 0, 0. We don't know how many zeros we're going to need just yet, but we'll have 3 for now. So when we say 6 goes into 1, or it doesn't go, so it goes 0 times. We can put the 0 in the decimal point, but the 1 gets carried over because we haven't used it. So now we say how many times does 6 go into 10? Well, it goes in once with 7, 8, 9, 10. That's a remainder of 4. So how many times does 6 go into 40? Well, 6, 12, 18, 24, 30, 36. 42 would be too many, so we're going to stop at 6 times, which was 36. And then 37, 38, 39, 40. So that's remainder 4. So we've got 40 again. So we're going to keep getting this pattern. So 6 into 40 is going to be 6 again with remainder 4. So in other words, it's going to keep going. Now, if we want to turn this into a percentage, we would multiply it by 100. So we've got 0.166. Yes, it's going to carry on, but we should have enough digits for now. We want to multiply that by 100. So we're going to move the decimal point once, twice. So in other words, we're going to get 16.6%, which hopefully, even though this number might be continuing, we can already see 16.6% is more than 16%. So this has got a bigger discount, so they should go to the, or they should use the Monday discount coupon. So which day should they go? Monday. Okay. Question 6. Work out the value of angle A. Okay, so we're going to use a rule we know about angles and triangles here, and I know that the total angles in a triangle, and this is in any angle, in any triangle, add up to 180 degrees. Okay, well, we know this angle is 25 degrees. This angle, well, this is a right angle, so I know that's 90 degrees. So if we add these two together, we can take them away from 180, and it'll give us our missing angle. So we want to add 90 and 25 together first of all. 0 plus 5 is 5, 9 plus 2 is 11. So we've got 115 degrees for these two angles. So this must be the rest that we need to take it up to 180. So in other words, 180 minus 115. So we want 0 minus 5, which we can't do because 5 is bigger than 0. So we take 1 from here, make that 7. This now becomes a 10. So 10 minus 5 is 5. 7 minus 1 is 6. 1 minus 1 is 0. So we're left with 65, which we can put in our answer box down here. 65 degrees. Question 7. A clay pot has mass equal to 2,650 grams. The volume is 1,000 centimeters cubed. Work out the density of the clay pot. Okay, well, the density is going to be the weight, or the mass, so grams, per centimetre cubed. We've got 1,000 of them, so we're going to need to divide 2,650 by 1,000. 3 zeros, so we're going to have to move our decimal point, which is at the end of the number, 1, 2, 3 times to here. So we end up with 2.65 grams per centimetre cubed. We have got the 0 there, which you can put on if you want, but you don't need it because it's after the decimal, it's at the end of the number, so we can just leave it as 2.65. Question 8. Riley wants to become a local football coach. Riley uses this table to find out how much other local football coaches charge. So we've got A, B, C, D, E, F, G, 7 different coaches. They're charging amounts, £25, £20, £30. Riley uses this formula to work out how much to charge. And we've got P equals 1.1 M, where P is the amount Riley will charge per hour in pounds, and M is the mode of the numbers in the table. How much will Riley charge per hour? Well, when you've got a number next to a letter, it means that we're going to multiply them together. We just need to work out what our m is. And it says it's the mode of the numbers in the table. So it's the number that occurs most often. So let's see how many times they occur. So 25 occurs just once. We've used that one. What about £20? We've got 1, 2. So that occurs twice. £30, just once. £40, once. £26, once. And £35 once. So the number that occurs most often is £20. So that's our mode. So what we want is 1.1 times 20. So we can ignore the decimal point, ignore the 0. So we just end up with 11 times 2. 1 times 2 is 2. 1 times 2 is 2. Now we want to add on the 0 to make it 20. But because we've got one decimal place, we're going to then put a decimal point in here. So we end up with £22. Okay, looks sensible. And that's the end of the non-calculator section. Now we're on to the calculator section. Question 1. Write 5,300,000 in numbers. Well, as I read that, 5 million, I put a natural pause here, 300,000 in numbers. I'm going to use these commas here. So we've got 5,300,000. We haven't got anything else, so we're going to have to put 3 zeros. We've got no hundreds, we've got no tens, we've not got no units. Question 2. Put these numbers in order, starting with the lowest. Well, the first thing I'm going to do is going to put commas in here so I can read the numbers properly. So starting from the end, we go 1, 2, 3, comma for the thousands. 1, 2, 3 for the millions. Same here, here and here, and here. I know they put the spaces in, but I find it much easier with commas in. Okay, so we want to start with the lowest. Well, the lowest numbers are going to be the negative numbers. They're going to be smaller than the two positive ones. So which one is more negative? So minus 948,000 compared to minus 34,000. So this is more negative. So minus 948,750. Then minus 34,589. Now these two numbers are both positive. So which is the smallest of these two? This is 1,004,000. This is 1,020,000. So we're going to have this number next. And finally 1,020,845. Question 3. Last week it took 2 gardeners 4 hours to mow a field. This week there will be 5 gardeners available to mow a field of the same size. The gardeners all work at the same speed. The manager thinks that the 5 gardeners will mow the field in less than 1.5 hours. Is the manager correct? So let's start off by working out how much work is there in total. Well, there's 2 gardeners taking 4 hours. So each gardener takes 4 hours. So 4 hours for one gardener and another 4 hours for the other. So 2 lots of 4. We can use our calculator now. So that's 8 hours of work. We've now got 5 gardeners. So we can share the 8 hours by those 5 gardeners, which gives us 1.6 hours. The manager thinks they can mow it in less than 1.5 hours. Well, no, 1.6 is more than 1.5 hours. So is the manager correct? No, they're not. Question 4. Put these fractions in order, starting with the highest. Right, okay, so we've got all of them starting with a 2. And they're all proper fractions. So we can ignore the 2 on all of them. We just want to know about the fraction parts. Best way to do this is use our calculator again. So instead of 4/9, we can say 4 divided by 9. So this, well, if we put the 2 in, this is going to be 2.444 recurring. This one, 5 divided by 6. So it's going to be 2.833 recurring. Here we've got 2/3, and add on the 2. We're going to have 2.666 recurring. And with the last one, 13/18. Add on the 2. And we get 2.722 recurring. So we want to start with the higher. So which is the biggest number? We've got 2.8 something. So it's going to be this one. 2 5/6. If you use that, then 2.7 is going to be next. So 2 13/18. Then this one's next biggest. So 2 2/3. And finally 2 4/9. Question 5. The diagram shows a square-based pyramid. Draw the plan view and side view of the pyramid. And we've got some dotted sort of grids paper below. It's a square-based pyramid, so we can just draw a square. We haven't got a scale or anything, so I'm just going to do 1, 2, I'm going to do 3 squares down. 1, 2, 3 squares across. So the plan view, we're looking directly down onto this shape. We would see a square. What we would see is we'd see the point right in the middle here. And so we'd see the edges sloping down. So it would look something like that. Now the side view, well, if we're looking from here, we would see, well, we know the width of the shape is 3 because it's going to be the same as the plan view. And well, we don't know how tall it is, so it's for us to decide on our diagram. But we know that the point is going to be in the middle, so if this is 3 squares across, the middle is going to be here. So let's follow it up. Let's say there will do. So although it's a pyramid, if we're looking at it from a side view, so it could be any side looking this way for example, side, it would just look like a triangle. So long as we've got the base is the same width as the plan view, the height could be anything because they haven't given us that information. So that's all we're after. Question 6. Hansa wants to put a square trampoline in a garden. One side of the trampoline is shown on this grid. If I move it up, you'll be able to see. There it is there. Okay. And the question is, where could the other 2 corners of the trampoline be placed? Now it said it was a square trampoline. Well, we've got 1, 2, 3, 4 squares. So it's either going to be 4 squares down this way or 4 squares up this way. I'm going to do them down just so that I can see them all on the paper at the same time. So 1, 2, 3, 4. So we could have a corner here. 1, 2, 3. Corner there. So I'm going to draw this on as well so you can see the sides of the square. So we want the coordinates. Well, we want this coordinate first of all. Well, it's -6, -7. And this coordinate is -2, -7. You could also have, let's say, also put that on there. We could also have the coordinates if we went up in the other direction. So if we put them up here, 1, 2, 3, 4, we'd end up with -6, 1. And the other one would be here, which would be -2, 1. So it doesn't matter if you put this pair of coordinates or this pair. Question 7. Quinn bought a mobile phone. The next day, Drew buys the same type of mobile phone in a sale. Drew got a 32% discount and paid £170 for their phone. How much more money did Quinn pay for the mobile phone? So Drew got a 32% discount, which means if we do 100 minus 32, that he only paid 68% of the original price, okay, which is £170. So what we want to work out is what was the original price, how much did Quinn pay for it, and then we can work out the difference. So if £170 represents 68%, well, the first thing we can do is work out what 1% is. So divide it by 68. Let's do it one step at a time. So we'll do this 170 divided by 68. So that's £2.50, and that's for 1%. Okay. Well, actually, we could work out 100 and then take it off, which is what I'm going to do, but then I'll show you a shortcut as well. So if that was for 68%, if we want 100%, well, we want 100 times £2.50, which means the original price was £250. So if it was £250, Drew paid 170. The difference between those is £80. Now the shortcut I mentioned, actually let's leave it up there, is we said £2.50 is 1%. We know that Drew got a 32% discount. So basically he saved 32 lots of £2.50. So if we'd gone straight in with that calculation, 32 times 2.5, and I'll just fence that off because this is like an alternative, we'd also get the £80. But I think it's probably easier to follow if we think, well, let's work out what the original price is, take off what Quinn bought, and that gives us a saving for Drew. Question 8. This table shows how long Tommy spends on different tasks at work. So serving customers is 210 minutes, working in warehouse 50 minutes, paperwork 60 minutes, stocking shelves 100 minutes. Tommy wants to know what fraction of time is spent doing paperwork. Tommy works this out to be 1/6. Has Tommy worked out the correct fraction? Okay, well, let's work out the total amount of time spent working first of all. So we want to add these all together. So 210 plus 50 plus 60 plus 100. So we've got a total of 420 minutes. Now, a fraction of time spent doing paperwork, well, that's going to be 60 out of 420. And what I'm going to do is I'm actually going to work this out as a percentage. So I'm going to multiply that by 100. So 60 divided by 420 times 100 gives me 14.285, so we'll round that up to 6%. Now we need to compare that to 1/6. So we can do the same, we can multiply that by 100 to turn that into a decimal. So we've got 1/6, or 1/6 times 100 is 16.66, let's round it up, 7%. So that should make it nice and easy to compare. Tommy works out the amount of time spent doing paperwork as 16.667. We know that it was actually 14.286. Has Tommy worked out the correct fraction? No. Otherwise, these two numbers would be the same. You can do it differently. When you've got the 60 over 42, you could take off the zeros and then simplify this fraction, and you would see that if you divide top and bottom by 6, you end up with 1/7, which still isn't equal to 1/6. But I think because you've got your calculator, turn them into decimals or turn them into percentages, and you can compare them that way. Either way is absolutely fine. Question 9. Bo needs to paint the outside of this cylinder, including the top and bottom. And we've got our diagram of a cylinder here, 60 centimetres tall. This is our circle at the top, 50 centimetres across, so that's our diameter. Bo thinks the total area to be painted is less than 15,000 centimetres squared. Is Bo correct? Show how you decide. Right, well, I'm just going to do a dotted line so we can see, well, we've got the top, the bottom, and then we've got this sort of wraparound bit in the middle, the rectangle. In fact, let's do a little sketch for that. So if we folded this out, because it's the surface area we're after, we'd have a circle, we'd have a rectangle that wraps around, and then we'd have another circle. Well, it doesn't matter where we put the circle down here. So we need to work out the area of each of these shapes. Okay, so let's start off with the area of the circle. And there's a formula for that, which is pi r squared, where pi we can use 3.14 because they've told us down here, and r is the radius. Well, the radius is half the diameter, so radius is going to be 50 divided by 2. We can use our calculator. So it's 25 centimetres. So the area is going to be 3.14. When you've got a symbol or a letter next to another letter or a number, it means you multiply 25. And because it's squared, it means we're multiplying it by itself as well. So the area of that circle is going to be 3.14 times 25 times another 25. So 1,962.5 centimetres squared. That's for the circle. Okay. Now we want to work out the area of this rectangle, so like the label, if you think of this all unwound and stretched out. So we've got our rectangle, and we know that the area of a rectangle is the length times the width. So we've got one dimension, so we know that this is 60 centimetres. We need this distance across here. Well, that's going to be the circumference of the circle. And the circumference of a circle, well, you can use either 2 pi r or pi d. Now we've got both. We've got the diameter and the radius, but we might as well use this one because you only need two numbers. So it's going to be 3.14 times the diameter which is 50. So 3.14 times 50, and we get 157 centimetres. So the area of the rectangle is 157 times 60, which gives us 9,420 centimetres squared because it's area. So our total area to be painted is going to be the top, which was this circle, 1,962.5 centimetres squared, plus the bottom, which is going to be the same, and then plus the rectangle wrapped round, which is our 9,420. So let's add these all together. We've already got that in the calculator, so we can just add on 1962.5 plus another 1,962.5, which gives us a total of wait a minute, I think I pressed the wrong button. Let's check this again. So we had 9,420 plus 1,962.5. I don't think I put my decimal point in properly. And another 1,962.5, which is 13,345 centimetres squared. Now it's always good to check your working as you're going. I knew something wasn't quite right because I can see this is about 2,000. That's about 2,000, so 4,000. 4 plus 9,000, I should have 13,000 something. So as soon as I got 31,000, I knew I'd done something wrong. So do look at your calculator numbers. Don't just trust everything. You might press the wrong button, or the calculator might have a funny moment and not pick something up properly. So we know the actual area to be painted is 13,345 centimetres squared. That is less than 15,000 centimetres squared. So is Bo correct? Yes, they are. Okay. Question 10. The table shows how far Alex walked each day for 2 weeks. And we've got it split into week 1, Monday, Tuesday, Wednesday, Thursday, Friday, and week 2, Monday, Tuesday, Wednesday, Thursday, Friday. Was Alex more consistent in week 1 or week 2? Well, when we're looking at how consistent they are, we're looking at the range, or the difference between the smallest and the largest value. So in week 1, the smallest value is 2, the largest is 9. So the range for week 1 is going to be 9 minus 2, which is 7 miles. And for week 2, the largest value is 7 and the smallest is 3. So the range for week 2 is going to be 7 minus 3, which is 4 miles. So was Alex more consistent in week 1 or week 2? He's got a smaller range in week 2, so week 2, because it has a smaller range. Question 11. Jamie is planning an event for 280 people. There will be 3 different ticket types available. The ticket types are standard, premium and luxury in the ratio 5 to 3 to 2. Jamie needs to know how many of each ticket type there will be. Complete the table for Jamie. Right, so we need to do a ratio table. Let's fit one in over here. And we're going to need 1, 2, 3 columns plus 1 for the total, so that's 4. So we can have 1, 2, 3, 4. So we've got standard, premium, luxury and total. We know the ratio is 5 So every time we've got 5 standard tickets, there's going to be 3 premium, 2 luxury. If that's all we had, 5, 3 and 2, plus 3 plus 2, we would have 10 in total. But we haven't got 10, we've got 280. So how many lots of this row would get us up to 280? So we can work backwards. We can say, well, 280 divided by 10 is 28. So in other words, I'm multiplying that row by 28. So we can do the same with all of these. We're going to multiply everything by 28. So 28 times 5 is 140 standard tickets. For premium, we're going to have 3 times 28 is 84 premium tickets. And 2 times 28, we've got 56 luxury tickets. And we can check, because if we add all of these together, 140 plus 84 plus 56, it should give us 280. So now we can write these values in here. 140, 84, 56, and a total of 280. Question 12. Damian sells cakes in the shape of a cylinder. The diameter of each cake is 15 centimetres. Damian puts a ribbon around the outside of each cake. Each ribbon needs to be 56% longer than the distance around the cake. How long does each ribbon need to be? Okay, so it's a cylinder, which might get you thinking, oh, okay, we've got a 3D shape here. But actually, we're just talking about the ribbon. We're just talking about the distance going around it. So although it's a cylinder, really, we're just talking about a circle. Okay, and a circle with a diameter of 15 centimetres. Okay, so the ribbon needs to be 56% longer than the distance around the cake. Well, let's work out the distance around the cake. Or in other words, the circumference, which we can work out as pi d, which is 3.14. We're told we can use for pi, times d, which is 15. Which gives us 47.1 centimetres. Now it's 56% longer. So let's work out 56%. So 56 out of 100 of 47.1 times 56 divided by 100. We get 26.376 centimetres. That's the extra bit. So we need to add it on to the original. So 26.376, add on the 47.1, we get 73.476 centimetres. Question 13. Riley wants to buy milk from a local farm. The farm has these prices on its website. Glass bottles, £1 a pint. Plastic bottles, £2.30 for a 2 litre bottle. Which type of bottle is better value for money? And we're told use 1 litre equals 1.76 pints. Right, so we want to get these in the same units. So either both in pints or both in litres. Now, if we know 1 litre is 1.76 pints, I think it's going to be easier to turn it from litres into pints. So if 1 litre is 1.76, 2 litres is going to be 2 lots of 1.76. Which is 3.52 pints. Well, how much is it for 1 pint? Well, it's going to be our £2.30 divided by, and we can do it as 3.52. So £2.30 divided by 3.52, and that's 0.65. We'll just do it as 2 decimal places, round down, and that's in pounds. So 0.65 pounds or 65p, and that's per pint. And that is less than £1 a pint. So we would go with plastic bottles. Okay. No, we can't fit the whole question in, so we'll move it up when we get down there. Question 14. Lay needs to paint this wall 3 times. Okay, and we've got the walls in the shape of a triangle, so 4.5 metres high, 11.5 metres across. But remember, I say it's a triangle, it's not a rectangle. Paint is available in these colours. So we've got white, grey, black, charcoal, cream, and we've got different amounts of area covered, or number of square metres, per each tin. So in other words, charcoal is probably a smaller tin, white covers more, so it's probably a bigger tin. Lee chooses the colour that will cover the median number of square metres. How many tins of paint does Lee need to paint the wall 3 times? Show your working. Okay, right, so first thing we want to do is work out what colour he's going to use, or at least going to use. So we want the median number. The median is the middle number when ranked from smallest to largest. So what's the smallest? That's the smallest, 6. Then 8, then 12, and 13, and 14. So if we write these in order, we'd have 6, then 8, then 12, then 13, then 14. So we'd cross out the smallest and the biggest, keep doing that in pairs till we're left with 1 in the middle. Okay, so we're going to go with black paint, which covers 8 metres squared per tin. But what we need to do is find out how much wall we need to paint. Okay, and the area of a triangle is equal to 1/2 times the base times the height. Or you can think of it as a rectangle, which would be length times width, divided by 2, because it's half, chopped in half here. Okay, so we want 1/2 times the base, which is 11.5, times the height, which is 4.5. So for 1/2, we can type in 0.5, or we can do 1 divided by 2, times 11.5, times 4.5. So we've got 25.875 metres squared per wall. Now we need to remember that it says, how many tins of paint does Lee need to paint the wall 3 times? So that's the area for 1 wall. We want to multiply that by 3. And we get 77.625 metres squared. Okay, so 77.625. Each tin of black paint, because it is, it was 12, so that was the grey paint, this one here. So we're going to divide this by 12. That's going to tell us how many tins we need. 6.46875, but you can't buy 0.46875 of a tin, so we need 7 tins. And finally, question 15. Cass owns a cleaning company. Cass uses this table to record time spent at each cleaning job. So there were 11 jobs which took between 0 and 60 minutes, 36 jobs that took between 60 and 120 minutes, 18 jobs took between 120 and 180 minutes, and 5 jobs took between 180 and 240 minutes. Cass thinks the mean amount of time per cleaning job is less than 104.75 minutes. Is Cass correct? Right, so we want to work out the mean. And the mean is equal to the total divided by the frequency. Now the total, we've got to think, total what? Well, it's the total number of minutes for all of these jobs. But at the moment, we don't know the actual time for each job because we've got these ranges. So what we need to do, we can't really use the big and small numbers, so we're going to work out the midpoint. So in other words, we're going to say all of these jobs is between 0 and 60, so we'll assume that they all take in the middle. And the way we work out the middle number is we add the bottom and the top, so the 0 and the 60, and divide it by 2. So we get a midpoint of 30. We do the same with the next one, so 60 and 120, divided by 2. Halfway in between would be 90. Next range, 120 plus 180 divided by 2, get 150. And same again with the last one, 180 plus 240 divided by 2, we get 210 minutes. So we don't need these anymore. We're now using the midpoint. And we're still after the total amount of time. So this is just the time per job. We've got 11 jobs that took this time. So we're going to need to multiply these together. So 11 times 30. So that means all of the jobs in this range took a total of 330 minutes. And all of these jobs took 36 lots of 90. So 3,240 minutes. These jobs, we had 18 jobs that took 150 minutes each. So that's 2,700 altogether. And we had 5 jobs that took 210 minutes each. So that's 1,050. So the total of all of them put together is going to be these added up. So we've got 1,050 at the bottom, add 2,700, plus 3,240, plus 330, which gives us 7,320 minutes. Now if you remember, we said we want the total, so 7,320, divided by the frequency. Well, the frequency is going to be the total number of jobs. And to do that, we're going to add these up. So 11 plus 36 plus 18 plus 5. So we've got 70 jobs there. 7,320 divided by 70 gives us 104 point. They gave their numbers to 2 decimal places, so we'll do the same. 104.57. This is less than 5, so we can just leave it like that. So 104.57 minutes. Well, that is not a lot, but it's slightly smaller than 104.75 minutes. So is Kaz correct? Yes, they are. So that's the end of the paper. Hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on so you find out when I load more videos, and I look forward to seeing you again soon. Thank you.